Swayam Prabha. Digital India. Educated India.
Welcome to the open course on diffusion in multi-component solids. This is the 14th lecture, and in this lecture we will try to prove summation cos square theta I goes from 1 to z is equal to z by 3. This is true for any cubic lattice. This will help in visualizing how the nearest neighbor atomic jumps occur in various directions in a cubic lattice, which may be simple cubic, BCC or FCC. So, we have gone through the fixed law equation, and we also derived the equation for diffusion coefficient based upon atomic jump frequencies. We obtained d equal to 1/6 alpha square gamma for any cubic lattice, maybe simple cubic, FCC or BCC. Right. In this equation, alpha denotes the jump length and gamma is the successful jump frequency of an atom. Okay, while deriving this equation, we use this right. Z is the coordination number. So, any atom has z possible atomic sites on to which it can jump, and theta I is the angle that a specific jump vector I has with the diffusion direction. Okay. So, we will try to show this for all 3 cubic lattices. Okay. This was an exercise that I had given you. So, let us try to derive this for all 3 lattices. So, if we consider for simple cubic, in simple cubic, what is the coordination number? That so coordination number 6, which means any atom has 6 nearest neighbors, or any atom has 6 possible sites onto which it can jump. So, if we consider this particular atom at one of the corners, so we can show the 6 nearest neighbors. So, 3 of them in this lattice itself, and 3 more, 1, let us call this plus x direction. So, our x, y, z are this one, x, y and z, right. So, in plus x direction into the next lattice, 1 on this side and 1 in the z direction. So, there are 6 neighbors. If this particular atom has to jump, and if this is x direction is our diffusion direction, so I goes from 1 to 6. So, what are different angles theta I? So, this atom can jump either onto this side, the theta for this is, so let us call it theta 1. So, cos theta is 1, or it can jump exactly in the reverse direction, that is minus x direction. So, theta 2 for this is 180 degree. So, cos theta here is minus 1. Then these 4 atoms, if these are the jump vectors 1, 2, 3 or 4, they are all making angle of 90 degree with the diffusion direction, right. So, theta 3, 4, 5, 6, they are all 90 degree. So, cos 90 is 0. So, if we take summation cos square theta I from 1 to I is from 1 to 6 for the cubic lattice, we will have 1 plus 1 plus 4 times 0, which is 2, or it is 6 by 3, and 6 is the coordination number for simple cubic lattice. So, sigma cos square theta I is z by 3. Let us consider next for BCC. If we draw unit cell of BCC, and if we consider the body centered atom, the coordination number for BCC is 8, which means there are 8 nearest neighbor. So, for the body center, if we consider, all nearest neighbors are located on the corner sides, right. So, we can see if this is our x direction, okay, let us call this x, y, z. If this is the diffusion direction, then we have 4 angles here, 4 jump vectors which are making the same angle. Right, let us call it theta, and there are 4 other jump vectors, and the angle they are making with the jump direction are obviously by symmetry pi minus theta. Right. So, let us try to find out what is this angle theta. Okay. So, let us use this one. Suppose the jump vector is to 1 1 1 side. Let us consider this jump vector. Let us try to join this with the body center atom on the next cube, right. So, the center atom, let us call this site as O, this is A and this as B. So, the coordinates for atom O are half, half and half. For A, what are the coordinates for A? 3 by 2 in x direction, half in y and half in z. Right? This is the corner, this is the origin, typical origin, right. And for B, the coordinates are obviously 1 1 1. So, what should be the cos theta? So, this is the diffusion direction, which is OA bar, and the jump vector we are considering is OB bar. So, cos theta should be, how do we find out cos theta? Dot product, yes, correct. So, if we take the dot product of the two, OA bar dot OB bar is equal to magnitude of OA times magnitude of OB times cos theta. So, cos theta is equal to OA bar dot OB bar divided by magnitude of OA bar magnitude of OB bar. So, let us see what is OA bar now. OA bar is 3 by 2 minus half is 1, half minus half 0, 0, and OB bar is OB bar 1 minus half, 1 minus half, 1 minus half, which is half, half, half. So, my cos theta will be the dot product of 1 0 0 and half 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 would be 1 times half plus 0 0 plus 0 times half divided by magnitude of OA bar would be square root of 1 plus 0 times magnitude of OB bar is half square 1/4 plus half square 1/4 plus half square 1/4. So, this should be 1/2 divided by root 3 by 4, root 4 is 2. So, root 3 by 2 should be equal to 1 by root 3. So, obviously, cos pi minus theta would be minus 1 by root 3, right. That is the angle that the reverse jump vectors make, right, on this side. So, summation of cos square theta I, where I equal to 1 to z, z in this case is 8, would be 4 jump vectors making 1 by root 3 plus 4 jump vectors making minus 1 by root 3. So, that should be equal to 8 by 3, which is again z by 3. Okay. So, this you can show in for any diffusion direction, right. We are showing for one particular, but you take any diffusion direction and you will get the same result. Now, let us consider for FCC. For which the coordination number is 12. So, easiest way to visualize this coordination in FCC is to consider stacking of 1 1 1 plane, right, which is the closest packed plane. So, if we consider the 1 1 1 planes, within plane there are 6 neighbors. So, they are basically in an hexagonal arrangement. If we consider this atom at the center, there are 6 neighbors in plane. So, the 6 are left. How are the remaining 6 arranged? So, remaining 6 are out of the plane, right. So, and they are arranged in a way 3 are on the top plane, the plane lying above this 1 1 1 plane, and the 3 are in the plane below it, this way. So, how many different types of jump vectors are there depending upon the angle that they make with the diffusion direction. So, suppose our diffusion direction in this case is this one. So, let us say call it I. angle that it makes with diffusion direction. So, cos theta I, cos square theta I, and then number of jump vectors that make this particular angle theta. So, the first one is in the same direction as the diffusion direction, let us call this 1. So, there is only one atom which is straight in the diffusion direction, and it makes an angle of 0 degree, right. So, the cos theta is 1, cos square theta is 1, there is only one such jump vector. The second one is in the reverse direction, right, minus x, or in the reverse direction to the diffusion direction. So, let us call this 2, it makes an angle of 180 degree. So, cos theta is minus 1, cos square theta is 1, and again there is only one such jump vector. Now, what is the next type? So, if you consider in plane atoms, these two, what is the angle that they make with this diffusion direction, this angle? What is this angle? This is a hexagon, this is 360 and 1, 2, 3, 4, 5, 6, 360 by 6, this is 60 degree, right. So, type 3 is 60 degree. How many such atoms are there? Obviously, this one and this one, and also these two which are out of the plane, right, one on top, one at the bottom. So, 4 such sides which make the angle of 60 degree. Cos 60 is half. The cos square theta I is 0.25, and there are 4 such sides. And type 4 by symmetry, you know, these 4 are making angle of pi minus 60 degree or 180 degree minus 60 degree. So, this is 4, 4, 4, 4, type 4. They are making angle of 180 minus 60. So, cos theta is 0.5 minus 0.5, cos square theta is 0.25, and 4 such atoms, and 2 are left, 4 plus 4, 8, 9, 10, and those 2 are type 5. And what is the angle they are making with diffusion direction? These 2. -90 degree, right. So, cos 90 is 0, 0, and 2 such atoms. So, if you take the summation of cos square theta I, and I varies here for FCC from 1 to 12. So, we have 1 atom into 1 plus 1 atom times 1 plus 4 atoms with cos square theta of 0.25 plus 4 atoms with cos square theta of 0.25 plus 2 atoms 0, which comes out to be 1 plus 1 2 plus 1 3 plus 1 4, which is 12 by 3 or simply Z by 3. Clear? So, for any cubic lattice, we get sigma cos square theta I is equal to Z by 3, and so we get D equal to 1/6 alpha square gamma. Now, this cos theta, why we take cos theta? Because our diffusion direction is one direction, but the jump vector is making some angle to the diffusion direction, it is not exactly in the diffusion direction. So, if you take this jump, for example, its contribution to the plus x direction or to the diffusion direction is given by this projection, right. and thus projection is nothing but cos theta times the jump vector, right, because this length divided by this length is the cos theta. So, in this case we see it is exactly half. So, the cos 60 is half, the angle is 60 degree. In this case the projection is 0. So, any jump to this type phi atoms is not making any contribution to the diffusion direction, whereas this is exactly reverse jump. So, the contribution is -1, cos theta is -1. Okay, thank you.